Hello everyone, today I'll show you why the rotation matrix is the way it is. This matrix allows us to rotate any vector in two dimensions by an angle theta. So let's start. Imagine we have a vector p with coordinates x and y. This vector can also be represented as x times I plus y times j, where I and j are the unit vectors. More precisely, I has coordinates 1, 0, and the unit vector j has coordinates 0, 1. Okay, this is a representation of our vector p and our unit vectors I and j, and like any linear transformation, to find the new coordinates of p after the rotation, we just have to find the new coordinates of I and j after the transformation. Okay, now we have just rotated those unit vectors by an angle theta. Now we have to find the new components of I and j. Let's start with the unit vector I. This is the y component and this is the x component. And since the length of the unit vector I is just 1, we know from trigonometry that the y component of I is just sine theta and the x component of I is just cosine theta. So after this transformation, our unit vector I has coordinates cosine theta and sine theta. Now we have to find the coordinates of the unit vector j. Same thing, as you can see, this angle must be 90 degrees since we are rotating by the same angle I and j. So as you can see from this picture, the x component of j is just the cosine of theta plus pi over 2, since pi over 2 is 90 degrees. And the y component of j is just the sine of theta plus pi over 2 radians. So after our transformation, the unit vector j has coordinates cosine of theta plus pi divided by 2, and the y component is sine of theta plus pi over 2. Okay, so this equals cosine theta times cosine of pi over 2 minus sine theta times sine of pi over 2, and the y component is just sine of theta times cosine of pi divided by 2 plus cosine of theta times sine of pi over 2. And now since cosine of pi divided by 2 is just 0 and sine of pi divided by 2 is just 1, this weird vector right here has just coordinates minus sine theta and cosine theta. Now we have the coordinates of I and j after the rotation. So to get our rotation matrix, we have just to put the columns together. So this is just cosine theta, sine theta, minus sine theta, cosine theta. And this is our rotation matrix. And if you multiply this matrix by a vector x, y, you notice that you get the coordinates from the previous video when we rotated the sine function. If you enjoyed my video, leave a thumbs up, share this video with your friends. Until next time, bye.